Alrighty, we are recording. All right. Share my screen. Ready. All right. All right, Cedric.
Let's go. Hello, this is a paper presentation, a group paper presentation on Internet of Things digital forensic. My name is Cedric Ifeanyi Ofebu.
My name is David Bonzar.
My name is Satya Sahiti.
My name is Sai Pawan.
So we'll be looking at the overview. What is an IoT device? Introduction of IoT forensic. Three-dimensional framework for IoT forensic. Temporal, spatial, and technical. Challenges in IoT forensic and modern cyber forensic techniques for IoT. Future directions in IoT forensic. Then the conclusion. What is an IoT device? An IoT device is any physical object embedded with sensors, processors, and communication technology that allows it to connect to networks. IoT devices operate autonomously, collect and transmit data, and often interact with cloud-based services. Examples: smart home devices, industrial sensors, medical implants, wearable devices, smart vehicles, and network cameras.
Coming to Introduction to IoT Forensics, the Internet of Things is a vast network of interconnected smart devices that continuously collect and share data. IoT Forensics is a branch of digital forensics that deals with data acquisition, examination, and analysis of IoT devices. The major challenges include data volatility, device heterogeneity, privacy concerns, and multi-jurisdiction legal complexities. This studies examines of IoT forensics through three key dimensions. Those are temporal, spatial, and technical. Next slide, please.
All set.
Next slide, please. The three key dimensionals of IoT forensic process are temporal dimension and collection and examination. And the analysis correlated collected data to reconstruct events and validate evidence, and reporting, documenting forensic findings for legal and investigative purposes. That's it.
Uh, I'll be talking about spatial dimension, where to find evidence in the Internet of Things. Device level, the first one being data extracted from smart appliances, sensors, wearables, and connected vehicles. And from network level, capturing Internet of Things communication logs, router data, and network interactions. And cloud level, examining stored user data, system logs, and device interaction history. The technical dimension, forensic tools and methodologies are IoT forensics tools. There are various tools that are listed, and AI-powered digital forensics that uses deep learning models to analyze Internet of Things behavioral patterns, and cloud forensics, digital forensics as a service to extract logs and metadata from distributed cloud platforms, and blockchain and cryptographic evidence ensures secure logging and immutable records.
Alrighty, the challenges in IoT forensics, Dev- uh, data volatility and ephemerality. The IoT data is constantly overwritten, making forensic acquisition time sensitive. This is just due to the size and uh, the the size and the use case of the IoT device. Device heterogeneity. IoT devices operate on various proprietary platforms, requiring diverse forensic methodologies. This is because of the proprietary format of some of the data that these IoT devices generates. The jurisdictional barriers, cloud-based evidence may be stored across multiple legal territories. A prime example of this is the AWS cloud. There are data centers all over the world, and they adhere to local legal um, restrictions. And the anti-forensic measures, the attackers can modify or erase IoT logs and forensic artifacts. And then modern cyber forensics techniques for IoT, the memory forensics that extracts volatile IoT volatile data from IoT devices before power loss. This is similar to RAM capturing. Network traffic analysis captures and analyzes packets to and from IoT communications. Machine learning and AI forensics. This is an AI-driven anomaly detection and automated event reconstruction. Essentially, here it's trying to play back what the device was doing. JTAG and off-the-chip techniques. This is actually uh, a physical access method to retrieve forensic data. This is actually removing chips off of a motherboard or a circuit board of an IoT device. And then blockchain forensics tracks IoT transactions and logs them in secure, decentralized environments. And then future direction in IoT forensics. This is to standardize IoT forensic frameworks to handle multi-vendor environments. We've seen this with some of the device proprietary features. Enhance forensic automation using AI-driven techniques. Again, this is just because the amount of data that the IoT devices can generate. Secure cloud forensics, leveraging zero trust architectures and digital forensics as a service. This is just, again, more efficient techniques for cloud forensics. Collaboration amongst law enforcement agencies to address legal and jurisdictional challenges. Again, this is just uh, a uh, a result of how the cloud environments are built out across the world. And lastly, blockchain and cryptographic evidence. This ensures secure logging in immutable records to ensure that the logs are not tampered with. In conclusion, the future of IoT forensics. IoT forensics is essential for cybersecurity investigations as IoT adoption continues to grow. A multi-layered approach is needed to collect, examine, and analyze IoT forensic evidence. Emerging technologies like AI, blockchain, and automated forensic tools will enhance the IoT forensic capabilities. And then finally, strengthening the legal frameworks and international cooperation is vital for cross-border forensic investigations. Thank you for your time. Have a good night.
Thank you.
Thank you.
All right, we are. All right.